Okay, so we have a good turnout already, so we're gonna start. And if anybody will join us late, you can always watch the recording that will be sent to you after the webinar end. So hello everyone and welcome to our weekly webinar. My name is Dor. I'm the Marketing Communication Manager here at SeaLights, and I'm gonna facilitate this webinar. This webinar is a practical guide on how to create and run efficient data-driven tests. With us today is Dimitri Harding, Solution and Tech Architect at the QualityWorks Consulting Group, and our very own CTO and co-founder, Alon Eizenman. If you have any question, feel free to ask them, but use the chat or even better, the question widget right here. We're gonna have a Q&A section at the end. If you need anything else from me, or you feel that you want some more information or to book a demo, you can contact me either here. If you press on my name, you can see my email, or you can send me a message here. And of course, through social media or through our website. I'm gonna now hand it over to Dimitri. Dimitri, the floor is yours.
Okay. Hi, everyone. So thanks for joining us today. And I'll get started. Thanks for the introduction, Dor. So what is data-driven testing? So a lot of persons hear the term data-driven testing. They don't really understand what it's about. So let's kind of break that down before we get into the practical usage of data-driven testing. So it's really about executing tests dynamically based on certain data. Your test is driven by this data. You can store what is to be tested, also what is to be verified. It also ensures that you have no hard-coded inputs and assertions in your test scripts, and we'll see why that is important later on. So visually, what does data-driven testing looks like, right? So we have a set of tests here. We see that this can look like a spreadsheet. You can consider this to be your data source. And this data source will have our test input. This test input will be acted upon with our test script, and then our test script will go ahead and perform some action on our application that is under test. The test script will also get the actual results based on the interaction that was done on the application, and then you'd have a phase where there is some assertion and verification that is done between the expected data that you had stored in your data source and the actual results that is coming from the interaction with the application. So we can see that this is like a loop where the data source has all of the relevant information in terms of what you're testing, your test input, and your expected results. Everything is separated in the data source, and then you just have your test script that's just taking that information and working on the application that you're testing. So why would we want to leverage data-driven testing? So there are a bunch of benefits, but these are just a few of them. So you want to reuse your test logic. And this is important because it also helps you to improve your test maintenance. There is less code for you to maintain because you're reusing a lot of it. You also are separating your data from your test scripts. This helps for you to be able to update your tests with your data alone without have to worrying about changing your code. This can make removing and adding tests really fast. And then overall, because you're able to add tests by just updating your data source, this allow you to increase your test coverage because you're able to test more by doing less work. So how do you execute data-driven testing? So most automation framework thankfully support dynamic tests. Some allow us to execute our tests from data sources like probably our database or your spreadsheets. But for data-driven testing to work, you have to think about how you're going to design your test upfront to ensure that you aren't taking on too much work, or if what you're testing makes sense to actually do data-driven testing. So what are some of these best practices? So we want to use realistic data when we're doing our data preparation, because this makes it much easier for us to test and verify things as realistically as possible. We want to ensure that our test scripts can handle different test inputs. So you want to check for those boundary errors where something might happen, but at the same time, you want to ensure that those errors are caught, so therefore they can be reported meaningfully. So therefore, if it was an issue with your script or if it was an actual issue with the test, you should be able to clearly tell the difference of why there was a failure. You want to ensure that your assertions are dynamic. So before in the diagram, I would have shown that you want to store your expected results as a part of your data set, because different inputs will have different results, and you want to be able to ensure that you're verifying the right data, even though your tests are dynamic. And then finally, you want to ensure that you're testing both your happy and negative paths in your testing, not just the happy parts, because you want to ensure that the coverage is for all of those use cases or scenarios. So when should you use data-driven testing? Well, you want to look at workflows that have multiple inputs and outputs. And later on, I'll talk about some different applications where we'll see, those patterns coming up. You also can look at your test code. So if you're creating your test code, you can look at the minimap or even just look in your text editor, and you can start seeing repetition. In cases like those, it's like a good indicator to say, hey, maybe you should try and use a data-driven approach where you take out all of the data out of your test scripts and just leave the logic in the test scripts and just supply the data to it, so therefore you can test more efficiently. So what are some of the data sources that you can use? So you can use MySQL or NoSQL databases like Firebase or MongoDB. You can use Excel or Google Sheets. Yes, Google Sheets is online, but there are Google APIs that you can use to pull data from Google Sheets. So therefore, you can use it as well as a data source. You have the common one, which is with our CSVs, comma separated value files. You have YML files, or you can use JSON, and the list goes on, but these are just a few of them. So what data source should you be using in your setup? The short answer really is you use a data source that kind of complement your current setup. So for example, say I'm working with a JavaScript framework, I might have a bias towards using JSON objects, depending on the data that I'm using, because JavaScript kind of support that natively. Or if it's that I'm doing something in Java, I might want to use maybe like an Excel sheet where there are plugins that are available that I can use to read the data from that Excel sheet and so forth. Also, if you're using like a specialized automation tool, you might want to check if there is a built-in data source option where you don't necessarily have to write any code. You just need to either specify the path to your data source, or you put in the value into the GUI that you're using. So some of those things are what you can look out for. And you want to use a data source that really works with your setup, whether it's the language or the tool that you're using, because you want to make it as easy as possible. So what are some of the advantages of data-driven testing, right? So you can easily test applications that have multiple inputs. So you can look at microservices. These are like your APIs. APIs are much easier to test compared to end-to-end or functional tests. A lot of it is very repetitive. So rather than hard coding how you want to test your APIs, you can use a data-driven approach to test more APIs with less time. Also, banking application is another good one where you have a lot of different forms that you might have to fill out as the user. Those forms provide different outputs, but the input is more or less the same. So you want to check different variations and so forth. Another advantage is also being able to test and verify data that are stored in one file. So you can, anyone on your team, even your CEO, even though they're not interested in testing, they can look at your test file to say, hey, these are some of the tests that I have running. They can look at it and say, oh, this actually makes sense based on what I see is being inputted as the test input, and also what is being verified, which is your expected results. And all of that is in one file that anyone can look at. They don't need to know to code or anything like that. The same test case that you have can be executed multiple times. So for example, you have your authentication or your login flow. You can log in as a valid user or an invalid user. The step to do that is pretty much the same. The only thing that's different is really what you're inputting and the error that gets thrown. So for example, you enter a valid password, email, you're able to enter the application. But if you enter a wrong password but the right email, then you'll get an error message to say, hey, something went wrong. So the flow is the same. Your automation would enter the values into the field and click your sign in or your login button, but the outcomes are different. Um, Also, by using data-driven testing, you don't have to worry about changes in your test script affecting your test data. So your test data is separate from your test script. So therefore, if you have your automation team that is working on the data-driven testing framework, and say you have maybe like your manual testers who are creating the tests and creating the test data, they can continue adding new tests. Your automation team can continue working on the data-driven test script, and those two teams can work simultaneously without have to worry too much about one affecting the other and basically blocking work from happening. And then finally, this allows for non-technical contribution to your test automation. So a lot of companies want to invest in automation, but finding the talent and the resources can definitely be a lot. So by taking like a data-driven testing approach where maybe you just have one engineer or maybe you could have one developer who is, open to helping you with your automated tests, they could explore the data-driven testing approach. They create a framework or a test script that works, and then maybe your manual testers on the team can supply those tests in whatever data file, and it just works. So that's one way to think of it. So we talk about the advantages, we talk about, how data-driven testing works. With everything in life, we have pros and cons of doing a certain thing. Data-driven testing does not solve all of your problem. This is not a technique that will say, okay, if you're doing automation, this is definitely the approach that you should be using. It's just a technique that your team needs to be aware of. So therefore, depending on the situation, they can choose this technique because it makes sense for the particular issue that you're having, right? So this skill is a very technical skill. So therefore, the test quality is very dependent on the programmer's skill who is writing the tests. So if your automation engineer is not very experienced in the language or the tool that they're using, there might be some edge cases in your test that they didn't account for, which can cause issues down the line. So you definitely want to use this technique with caution for sure, or consult experts if you have that at your disposal. The next thing is, debugging errors can be very tedious. especially as I mentioned before, if your automation engineer is not so experienced, because these issues are the issues that comes up with data-driven testing. They are not really about a test automation frameworks. Most of the times it's more about the language or the tool that is being used. So they have to have a very deep understanding, so therefore they can get the best out of it. So I wanted to just talk about a small demonstration of how data-driven testing would work. So right here, what we have is a tax calculator application, and it has multiple inputs for 52 states and their taxes, right? So you can test for what you can get the tax for one item, or you can get the tax for multiple items. So a test like this has multiple inputs because there are 52 states. Each state can have two ways in which you can calculate the tax. So that's 52 times 2 or 4 already, depending on how you want to look at it. So already we have about 104 tests, I believe. So all of these tests, they do take the same path. So you don't necessarily want to do it the normal way, which I'll show shortly. So possibly this is what your data source could look like. This is just a very simplified version. So you have all of your state names, you have all the tax percentage that they have. Then we have our item cost, we have our number of items. This can either be 0 or which other number that we want to supply. These first test case in this file doesn't have any numbers, but the other ones would have had. And then we have our expected results. So the good thing about using spreadsheet in this sense as a data source is that one, the tester doesn't necessarily have to do the calculation for themselves. They can use formulas in Excel sheets for the expected results. We don't have to worry about, hey, if they were supposed to be doing it on a calculator and making mistakes, then therefore that would kind of skew your tests, providing false positive. So that's another neat benefit. This is just to show you what it looks like. So if we were supposed to read that same file that we had before in, say, like JavaScript, this is what the JSON object would look like. So we have an array of objects where in each object we have an expected tax, item cost, number of items, state name, and state tax. Basically the same data, but just represented in another way. Okay, so this is what it looks like if the test was supposed to be repeated without using the data-driven approach. So if we look on our right, we can see the minimap, and you can start seeing that there is like a pattern because they are the same steps that you want to use for all the different states. I think this test file went on to about 1,000 plus lines of code just to get all of the states and all of the different scenarios that needs to be tested. And this is definitely the way that for this scenario or a scenario like this, you wouldn't want to do it. Also, this takes a lot of time for the tester to do. At some point, it just kind of comes like copy and paste. So you can definitely know that that's not an efficient way of doing it. So now we have a side-by-side comparison, right? And one thing that I want to show that is the big difference here is where we have line 2 on our right for a data-driven approach, where we're seeing that we're reading the data from a file. And then this data at line 17, well, at line 11, we can see that we're running a loop. So we're saying for each data set, we want to perform this action. And there is one additional thing that we need to mention is that if there is multiple items in the data set, we want to do one extra click. And we're just accounting for that by using an if statement. And then we have our dynamic assertion at the end. So this is only 31 lines of code. On our left, where we have the approach without using data-driven, this test file was about 1,000 plus lines. So we were able to drastically reduce the amount of code that we had to maintain, and also we still had the coverage that we needed to have from before, because each state we want to test that the tax is calculated correctly for one item or multiple items, and we had to do that for all of them. So I also wanted to show what it looks like in other frameworks. So this framework is WebDriver IO. It looks more or less the same as what we had before. This one is Cypress. It more or less look the same. The point of this is to say that data-driven testing, no matter the automation framework or tool that you're using, you can leverage it. It most likely will be the same. It's just reading data, looping over the data, and running your test based on the data that you have created. So yeah, we talk about data-driven testing, and we talk about how we can use it, and we talk about some of the patterns that we can look at. But I also want to mention some real-world projects that have actually used this technique, and what were the outcomes of using data-driven testing, just to show that it is very practical and not just like a buzzword or anything of the sort. So I was working on a project with a team of automation engineers, and we needed to automate microservices for a logistics company. So we have over 100 APIs that we needed to test. So based on that, we were able to use Excel sheets as our data sources. We were able to specify valid tests, invalid tests, and also we were able to prepare data that we needed to load into the database before doing our verification, all with data. So at the end of the day, we're able to load data into the MySQL tables that the same API would run the test against. That data will be pulled from the responses, and we were able to verify all the tests because we were supplying the data that was loaded in the database, and also the data and the tests lived in one place, so we're able to easily do the verification on these. So we had a faster turnaround on our API regression tests. We had a streamlined process for creating automated tests, because after the framework was set up, or at least after the test scripts were written, it only came down to just a process, knowing what endpoint to be testing, knowing what schema should be used, and knowing what data to be supplied. So at that point, anyone on the team really and truly could write API tests, even if they didn't know about automation. And this was also a good thing by leveraging this type of technique. The next project was, we were working with an entertainment company, and they wanted to switch payment providers. So they already have an existing payment provider, and I think they wanted to switch to another payment provider called Braintree. And they already had existing automated tests for their existing system, but we were able to refactor the existing automation code using data-driven testing and also using JSON as a data source to test both of the providers at the same time. We were able to pull data from the database and cross-reference the logic across both providers at the same time. This allowed us to find inconsistency between the results of the providers very earlier on in the project. So therefore, the developers were able to do their migration correctly, because they wanted their system to operate the same. It's just that they were adding new features on top of what they had, and also it was a different provider. So we were able to get more coverage with less code based on the refactor we did, leveraging data-driven testing. And finally, I'm sure all of you remember when GDPR came out, where a lot of companies had to be removing personal identifiable data from their systems based on user requesting that that information gets removed. So this was a movie review website. Once requests came in for the user data to be removed, the DBAs would run some scripts on their database to basically mask or get rid of the data. But we also needed a way to verify that the data was also being cleared from the UI, because they had some caching system. It was a very old system, so it took a day or two after the database was masked for that to be removed, but we needed to check it continuously to ensure that it was done. So what they would have done is to upload some user IDs to a S3 bucket. The automation would pull down the data from S3, and then it would go to the front end, find where the data lives in the UI, and just verify that the information is masked out based on what was supplied from the bucket. So the outcome of that was we're able to provide a hands-free verification for the data that was removed. And this was also a very minimal to manage over time. So what are some of the takeaways for using data-driven testing? So we want to leverage data-driven tests when we have multiple inputs and outputs. We want to use data sources that kind of already complement our setup, so therefore we don't have to spend any time looking for data sources or trying to understand how a data source would work with your setup if it's not compatible. We also want to ensure that when we're working on data-driven testing, we want to keep in mind that this technique will require persons with more programming knowledge to execute this properly. So we want to provide support or ensure that we give time that these tests can be created and tested before being used. And then finally, leveraging data-driven testing can improve our test maintenance, because then you'll have less code to work with, and it will also help in your test coverage because you're able to add more tests very easily compared to if you were supposed to manually add tests based on updating your test files and so on. So I'm done with my section and I'll hand it over to Alon.
Thank you, Dimitri. Yeah, we learned all about data-driven testing. Dimitri covered it very well. I must say, I see it a lot. I see it with many of our customers. It's already used by many of our customers. That's why we were asked to also support data-driven testing. I would want to start, discussing the next steps. Let's say you already implemented data-driven tests. What would you then expect, to see next when it's becoming, more extensive use of data-driven tests? What can risk their efficiency? So starting with several risks, and then I'll explain how we would SeaLights, help you handle with these, overcome those risks. So first thing, when you're focused on maintaining your test and keep up the relevant data sets, and then you run your test with your data sets, you're relying too much or entirely on passed or failed status from your test. It's not always sufficient enough. The thing is that you would also need to know how those tests effectively covering your important code areas. But the thing is that you don't have clear visibility of what the tests are covering. And I'm specifically talking about code coverage, how those data-driven tests covering your application code. Another thing is that you not necessarily be able to see exactly what whether the current modifications are covered by your test and specific data sets. And in many cases, the team that is maintaining the test or coding the test, not necessarily the team that is building up the data sets. So after a while, the data sets are piling up, and the cycles, without even noticing, the cycles are becoming really long, and then you would need to do something with that. You in some cases would not be able to even run all your tests for any build. Can you move next slide? So now drilling down into code coverage. So we do provide code coverage for data-driven tests. I'm going to explain what would you get out of that. So first thing, understand what data set might be missing. So by understanding, and seeing some specific code areas that are still not covered after you run, all your tests, all your data sets, you would maybe need to take a decision to add additional data sets. Also understanding what tests are missing with, older data sets, or a new set of data sets for the new test. So understanding, what tests are missing. Also, by having understanding of how tests are covering the actual code, you gain, the required confidence that you really not just running all your data sets, you're also covering your important code, and get the confidence that it's well covered and you can release it. That's taking into the next topic is, setting up the gates. So not just making sure that you run all your tests, all your data sets, but also meeting your code coverage goals with all these tests. And that's also in many cases needed to be able to also show a proof of testing for compliance reasons, how well your tests are covering your code. And sometimes, the auditor might come in and say, show me how you tested a specific build that was deployed into production. Then you can you can get a proper report for that. Next slide. So now talking about the specific changes, code changes. How would you align your data-driven test with the recent code changes? So when using SeaLights, you also get understanding of how changes are being covered by your test, and that would let you focus on the deltas. So when making a change, you would see that the change maybe is not covered by your current data sets, and maybe you would need to add, or that would remind you, to add some additional data sets. But with that, you can always focus on those changes and on the deltas. That would drive team efficiency. That would also, just understanding that you're releasing some code changes without covering them and do something, that would help you reduce the number of incidents that are being escaped into production. And that's also helping you to keep your test effectively covering your recent changes. Next slide. So now talking about the long cycles, as you keep adding more and more data sets, you have basically every data set, it's another test execution, basically. And the number of executions, number of data sets and execution is always increasing. I never saw a case, that the number of executions is dropping, but the thing is that the cycles are getting longer and longer, and in some phase you would like hit the wall. You would not be able to run all your tests. But then the other option is maybe cut down the number of executions, but having the need to run all your data sets, or you would not really understand which data sets can be skipped or which tests can be skipped. You will get into a situation that you would need to somehow compromise on your quality, or delay some of your releases. So now, next slide. So we have the ability to also optimize your data-driven test by selecting a subset. That can be a subset of tests with older data sets, or a subset of specific data sets for given tests. So we would understand what changed in your application code, and based on that, we would select this subset and run only the relevant tests, and also the relevant data sets for the given test that was selected. And with that, you cut down the number of test execution, shortening testing cycle time, and lots of benefits around that, because providing, for example, faster feedback to your developers. In many cases, developers might wait too long to get some feedback, and they would move on and do something else, and then they get some failures, and they do lots of context switching. So by having or by running only the relevant test, developers get the right feedback for the relevant test faster, and the number of context switching is dropping or even eliminated. And with that, developers' productivity is increased dramatically. Same goes for hot fixes. In many cases, hot fixes, you only have a very limited time, and you would need to run a subset. But if you don't have, like a smart way to select the test for you, you might end up, manually selecting a subset of your test or data sets, and that's very error-prone. Having a smart selection would increase the confidence of your hotfixes, and you would have the subset selected for you without compromising on quality. Run a subset and even shortening the hotfix release cycle further. So that's on a very high level. If you go back one, that's on a high level. If you want to hear more, you want to see a demo, you can use this to book a demo, and we'll be happy to show you more about SeaLights. So now, moving back to Dor for Q&A.
Okay, so Sanjeev, I hope I pronounced it correctly, asked how SeaLights will help in making tests more effective. If my test is failing in that case, also SeaLights will show the coverage, especially in data-driven test cases. For one data set, test will pass to test some logic or method of code and may fail for other data set. But coverage perspective, SeaLights will be publishing that you have the coverage for modified code.
Yeah, so everything that would run, so it depends on how you build your basically testing framework. If you built it in a way that the first failure it would stop, we would show you the coverage, also modified coverage, till the point it failed. But if you build it in a way that it will keep running all the tests, we would show you what you gained and which tests would and data sets actually failed. So it's always listening in. So once you start execution to the end execution, we would collect all the coverage from the application under test, and then build up all the analytics about what's covered, what's not, even across different type of tests, as well as how that's also related to the changes made.
We have another question. How do SeaLights integrate to the datasets?
So we are integrated with the testing framework. And the testing framework is basically running the test and the data sets, but we get kind of ID. We are not getting, the actual data sets. Sometimes it's too sensitive, and the test data should not be shared. And that's why, we keep kind of ID per data set. And then we have the same test running several times with different data sets IDs, and then we keep that and align it or map it to all the activities inside the application under test. Later on, we can show you, like you run the same instance of test with different data sets 100 times, and that's what you gain. And also when in the next build we identify the change, we can then create a subset of the same test with several and a subset of data sets IDs that will only be executed by the test framework. But we feed it into the framework, and the framework is responsible for running the test with those different data sets.
All right, so I guess you both did a good job because there's no more questions. If anybody want to ask a question, now is the time. If not, you can always approach Alon or Dimitri or myself, and I will get the question to Dimitri or Alon because they know way better than me. I want to thank Dimitri for being here and for this great webinar. And of course, thanks, Alon. We'll see you all in our next webinar. And you can always take a look in our website or on our social media to keep up to date and know when our next webinar is. So thank you, everyone. Thank you, Alon. Thank you, Dimitri. And have a great rest of the day or evening, depend where you are across the world. Thank you very much.
Thanks, everyone. Thanks, Dimitri.
One.